Hello everyone. In previous lecture we have discussed about the introduction of the swap agreements, and I have already discussed about the interest rate swap, and in this lecture we will calculate the price and the value of the interest rate swaps. I have one question here for interest rate swaps. The objective is to calculate the price and the value of the swaps. The question is, consider 1 year swap with a semi-annual interest payments. So it means that if I draw a timeline, the interest payments are semi-annual. Let's say this is 180th day and this is 360th day. So it means that first interest payment will be made at this point of time and other interest payment will be made at the end of 360th day. And the first requirement is to determine the fixed rate on swap. The term structure of the LIBOR is as follows. For 180 days, LIBOR is the lender interbank offer rate, which is 7.2% for 180 days, and for 360 days the LIBOR rate is 8%. Now first we calculate the price of the interest rate swap. To calculate the price of the interest rate swap, first of all we will calculate a present value factors for 180 and 360 days. So to calculate the present value factors, this P0 180 represents the present value factor for 180 days, and the formula is 1 over 1 plus interest rate. For 180 days, interest rate is 7.2%, and 180 by 360. So that's how we can calculate a present value factor. The answer is 0.9753. This present value interest factor is just like a present value interest factor formula, and the present value interest factor formula is 1 over 1 plus I raised to power n. So here 1 over 1 plus I raised to power n. So we are using the same formula to calculate a present value factor here. So present value factor for 180 days is 0.9753, and present value factor for 360 days is 1 over 1 plus, for 360 days rate is 8% into 8, and 360 by 360, the answer is 0.9259. So now we can calculate our objective was to calculate a fixed rate on swap agreement. So here we can calculate a fixed rate by using the formula of this. To calculate a fixed rate, actually the formula is 1 minus last present value factor 0.9259, whatever is the last interest factor. In semi-annual form, the last factor is the second factor, and quarterly, if you have a quarterly interest payments data, then the last interest factor present value factor will be the fourth present value factor. So divided by all present value, sum of the all present value interest factors, 0.9753 plus 0.9259, and the whole answer is 0.0392. So it means that fixed rate here is 3.92% per semi-annual, and for the swap agreement, one party will pay fixed rate of 3.92% on $1 notional principal. So in second requirement, and I have already discussed about the interest rate swap. In interest rate swap, one party pay fixed rate and other party pay floating rate, and floating rate depend upon the market, and the party who will pay floating rate, they will pay floating rate, whatever will be floating rate at the 180th day. We don't know what will be the fixed floating rate at the end of 180th day, and the same party who is paying the floating rate, they will pay the floating rate interest on $1 notional amount at a floating rate of 360 a day. So, but the other party is who will pay the interest rate on fixed rate. So the other party need, if one party go for a swap agreement and this party will have to pay fixed interest payment, then definitely first of all they will have to calculate how much fixed interest rate they should pay against the floating rate of LIBOR. So in this A requirement we have calculated that 3.92%. This 3.92% indicates that if we go for a swap agreement with other party, we should pay a 3.92% of interest rate against the LIBOR floating rate in this question. So B requirement is that 90 days later the term structure is as follows: determine the market rate value of the swap at 90th day from the perspective of one party paying floating, other receiving the fixed rate. Assume notional $15 million. So a requirement is to calculate a market value at the end of 90th days. So here we will calculate a value of this swap agreement at the 90th day. To calculate a value at 90th day, first of all we will calculate a present value at. Now we will assume that now 90 days has passed. So for B requirement we will assume that now we are here at 90th day rather than at 0 point of time. In A requirement we will assume that when we start any swap agreement we start from day first. So but B requirement is related to the 90th day. It's mean that in this question there is assumption that we have made an agreement. Two parties made an agreement that one party will pay 3.92% interest at a fixed rate to other party, and the second party will pay floating rate to the first party on $1 notional principal. And now 90 days later, the any of the party want to calculate, the party who is paying floating rate and receiving fixed rate want to calculate a value of the bond after 90 days. So now here we will calculate a value of the swap agreement which they have done at 0 point of time. Now we will calculate the value at 90th day. To calculate a value at 90th day, first of all we will calculate a present value factor at 90th day. So if we go for a swap agreement and one party will pay 3.92% interest rate at 180th day and 3.92% at 360th day. So in this B requirement, first of all we will calculate a present value factor for 90 days, these 90 days. So this 90 means that now we are calculating at 90th day, and the difference between 180 and 90 is 90. So it means that we are calculating a present value interest factor for 90 days, and we will use here formula 1 plus 0.071 into 90 over 360, and the whole answer is 0.9826. And again we will calculate at 90th day present value interest factor for 360. So it means that difference between 360 and 90 is 270 days, and the 270 day rate is 7.4%. This is the present value in factor for 270 day. So here we will put values 1 plus 0.074 and multiplied by 270 divided by 360, and the whole answer is 0.9474. Now we have a present value factor for 90th day and 270th day. Now we'll calculate a present value of fixed interest payments plus present value of $1 notional. So to calculate a present value of fixed interest payments and present value of $1 notional, here we assume that if we made a payment of 3.92% after 180 days, and other payment will made at the end of first year, which is 3.92%. So at the end of first year there will be a principal repay. So same like this in bonds, first interest payments made at the end of the bond, principal payback to the bondholders. So same like this, here we calculate a present value of fixed interest payment and present value of $1 notional principal. So to calculate a present value of fixed interest payments, we can calculate it as and the fixed interest payments are 3.92% and 3.92%, 0.0392 into we will discount back this value from this point to this point, because right now we are calculating the value at 90th day. So we will discount back this 3.92 value of 180 to 90 days. So from 180 to 90 days, the days are 90. 180 minus 90 is equal to 90 days. It means that we will discount back this value for 90 days, and 90 days present value factor is 0.9826. And then to calculate a present value interest factor for second interest payment, which is 0.0932, and we will discount back this value to 90 days. From 360th day to 90th day, the difference between 360 and 90 days is 270 days, and the present value factor of 270 days is 0.9474. So here we are calculating a present value by using the same formula which normally we use in finance courses. And formula is present value is equal to future value into present value interest factor. So here future value is 3.92% and present value factor is this. So future value is 3.92% and present value interest factor is this. And if we assume notional principal at this point of time, which is $1, so we can discount back $1 to the 90th day, from 360th day to 90th day. So to calculate the present value of notional principal, we will multiply this $1 by the 0.9474. So that's how we can calculate a present value of interest payment plus present value of notional amount, and the whole answer is here 1.0231. After calculating a present value of fixed interest payment, now we will calculate a present value of floating interest payment. Floating interest payment plus present value of $1 notional. So in floating, to calculate a present value of floating interest payment, we will use a first interest rate as a floating interest rate. So here first interest rate is 7.2%. So 7.2% is the annual rate. We can divide 7.2% by 2 and answer is 3.6%. So it means that here we are assuming that at 180th day the floating interest payment will be 3.6%, and here in this B requirement we are calculating a value of the swap at 90th day. So it means that this is 90th day. So here we discount 3.6% to 90th day, as well as $1 will discount $1 to the 90th day. So to calculate a present value of floating interest payment, which is 0.036, to now we want to discount back to the 90th day from 180th day, and the difference between 180 and 90 is 90 days, and we will use 90 days present value interest factor. Now this is the future value multiplied by 90 days present value interest factor, which is 0.9826, and plus $1 is the notional principal amount, and we will multiply this amount by again we are discounting this $1 notional from 180 to 90th day. So it means that we will use 90 day present value factor, and the present value factor for 90 day is 0.9826. So whole answer here is 1.0180. So now we have a present value of floating interest payment, present value of fixed interest payments. Now at third stage we can calculate a value of swap. Okay, so here now we go to the question part. Here requirement is to calculate a determine the market value of the swap at 90th day from perspective of one party. Now we will calculate from the perspective of one party rather than the perspective of two parties. From the perspective of one party who is paying floating rate, and receiving fixed rate. Paying floating rate mean when we pay any amount we will use negative sign. Paying floating rate, and the floating rate present value is 1.0180. And second is receiving fixed rate. So when we receive something, the sign is positive. So present value of fixed interest payment, which is 1.0231. Here we use negative sign because we are calculating the value of the swap with respect to the party who is paying floating. So paying floating means we will use a sign with present value of floating interest payment and plus sign with the present value of fixed interest payment. So whole answer here is 0.0051. That means that value of the swap is 0.0051 for $1 notional principal. Normally we do all calculations on the basis of notional $1 principal, $1 notional principal, and if this value is positive, it means that the swap is profitable, and if has some value, and if this value is negative, it means that we can say that in simple words the swap agreement is in loss. So now at the last we have in question there is a written that assume notional principal 15 million. We have done all calculations on the basis of $1 notional. So if the agreement between two parties, swap agreement between two parties has a value of notional principal of $15 million, we can calculate a value of $15 million swap by multiplying $15 million with 0.0051, because this 0.0051 is the value of the swap against one notional. So here we need to calculate a value of the swap against 15 million notional. Now we multiply 15 million to 0.0051 and the answer is 76,500. So it's mean that if the contract between two parties, interest rate agreement between two parties has a notional principal of 15 million, then after 90 days the value of the swap is 76,500 for the party who is paying floating rate and receiving fixed rate, and the value of the swap for the other party who is receiving floating and paying fixed rate, the value for the other party will be minus 76,500. Thank you so much. That's how we can calculate a price and the value of the interest rate swap agreements. Thank you so much.